In this example, we're given 3 probabilities, and we're going to use those to calculate more complicated probabilities. For example, Felicity from Modesto Junior College is considering enrolling in math or speech classes. If we know that there's a 20% chance that she enrolls in a math class, a 65% chance that she enrolls in a speech class, and a 25% chance that she takes math, given we know she's definitely taking speech, we can answer questions about the probability that Felicity enrolls in math and speech, and we can also answer the question about the probability that Felicity enrolls in math or speech. If we're looking at and, we're talking about in the same semester taking both math as well as speech. To do that, we need to recognize that these aren't necessarily independent events, but we can still use the multiplication rule here. We're looking at one semester, the classes that will be taken. We're looking at math and speech. Because we were given the probability of taking math, knowing that Felicity is taking speech, we can use that probability, 0.25, and multiply it to the probability of taking speech, which is just 0.2. Multiplying those two decimals together, we get about 0.1625. If we were to look at the OR probability, this is where we're using an addition rule, making sure to remove any overlap. So, knowing that it's possible for Felicity to take math and speech in the same semester, if we're considering taking math or speech, we could add the probability of taking math to the probability of taking speech, but we have to account for the possibility of taking both in the same semester. So for this one, we can add the 0.2 plus the 0.65, but we will need to subtract the probability we calculated in the previous step to make sure that we're not double counting the time where she takes both classes together. And if we can combine these decimals, we result in 0.6875. Now we might want to consider, are the two events independent? If they are, then the conditional probability would look just like the probability of taking math. We know they don't. The conditional probability is 25%. The probability of just taking math is 20%. They are not equal. Therefore, M and S not independent. We might also want to know, are the two events mutually exclusive? If they are, then the AND probability of math and speech would have to be 0. And we know it's not because we calculated it in the beginning. So since that probability is not equal to 0, we know these two events are not exclusive.